Hello and welcome to today's video. In today's video, we are going to discuss the nomenclature of unsaturated hydrocarbons. So we have to understand what is an unsaturated hydrocarbon. So in simpler terms, an unsaturated hydrocarbon is a hydrocarbon that is formed when we have a double bond or a triple bond between two carbon atoms. So when we have a double bond, we have what we call alkenes, and when we have a triple bond, we have what we call alkynes. Now, in this video, we are going to focus on alkenes. Obviously, we can even add cycloalkenes, but we'll look at this later. So for alkenes, I will give an example of an alkene called ethene. So this is one of the examples. We can have an alkene called propene. Remember, each carbon is supposed to make 4 bonds. Each carbon is supposed to make 4 bonds. So this will be called propene. Now, when we are using the IUPAC to name some of the complex compounds that carries a double bond, for example, we can have a compound such as CH3, CH2, CH2, CH, then CH2. So it's very important for us to identify the position of the double bond. So it's very essential that we identify the position of a double bond, which basically means that our counting should start from the carbon that is closer to the double bond. So in this case, the correct counting is going to start from here. 2, 3, 4, 5. So this will be considered as the correct counting. If we start counting from the other side as 1, 2, 3, 4, 5, this will be considered as a wrong counting. So we start counting where we are from a carbon that is closer to a double bond. So in this case, how do we write the name? So first, we state the position of a double bond. So this is 1. Then, what is the longest chain, or what is the name of the longest chain? So we have 5 carbons. So 5 carbons means pentene. So this can be called 1 pentene. So here we have identified the position of a double bond, and then we have given the name of the longest chain. This can equally be written as pent 1, then in. It's the same thing. So let's consider this as A. B, let's look at another interesting structure. Let's say CH2 double bond, CH, then CH2, CH double bond, CH2. So when we look at this particular compound, we have 2 double bonds. So if we start counting from the right as 1, 2, 3, 4, 5. So here, when we do the locant, we have a double bond at carbon 1 and we have another double bond at carbon 4. So this gives us a locant of 5. If I start counting from the other side as 1, 2, 3, 4, 5, it will still be the same thing. It's 1 plus 4. So meaning whichever direction of my counting I will consider is going to be correct. So here they are saying at position number 1 and at position number 4 we have a double bond. Then what is the longest chain? So the longest chain is still pentene 5. So this will be pentene, which can equally be written as pent. Oh, now that reminds me. So here, allow me to erase this. So this reminds me. So remember, we have 2 double bonds. This is very, very important to take note of. So we have 2 double bonds. So when you have 2 double bonds, 2 in chemistry means di. So we have to consider this di and then En. So this is going to be written as 1, 4, then pentadiene. So something like this. Or alternatively, this can equally be written as pent 1, 4, then diene. Pent 1, 4, then diene. So here what we're trying to do is we are just trying to give an emphasis on the position of the double bond. Let's look at another example, which is C. Something similar to what we have looked at. We have this, and we have CH2. Let's say we have another double bond there. So meaning this is okay. Yeah. So here we have to see which locant is going to be the lowest. So if I start counting from this side, it means this will be my first carbon, second carbon, third, fourth, and fifth. So meaning at carbon number 1 plus at carbon number 3, then plus at carbon number 4. Meaning my locant in this case is going to be 8. Then if I start counting from the other side, this is 1, 2, 3, 4, 5. So at position number 1, I have a double bond. At position number 2, I have another double bond. Then at position number 4. So therefore here my locant is going to be 7. So meaning the correct counting is when we use the other side. So here remember we have a double bond at position 1. We have a double bond at position 2. And we have a double bond at position 4. So 3 double bonds will mean that we're looking at a tri. So tri, then E and E. So to name this particular compound, we can say this is a pent, then 1, 2, 4, then trine. So that will be the name. of this particular compound. Now, let's look at more examples. In a case where now we introduce other substituents. So we have CH3, then we have maybe CH there, CH3, then CH, let's say CH, another CH3 here, then CH, we have a double bond, and CH, then CH3. So in this case, we are considering this as 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, the longest chain. So the longest chain is hexane, 6. So what this means is that this is a substituent and that is a substituent. So we have a methyl and another methyl. Now here we're going to have a dilemma in terms of what substituent to consider, or what key are we supposed to consider when we want to start counting. So whenever there is a double bond, so we give respect to a double bond. We give respect to a double bond. So the counting should start from a carbon that is closer to a double bond. So in this case, what this means is that my counting will start from here. So 1, 2, 3, 4, 5, 6. So my counting should start from where we are closer to the double bond, because if we start from the other side, which is 1, 2, 3, 4, 5, 6, we're going to notice that our double bond is going to be at position number 4. But when we start from this side, our double bond is going to be at position number 2. So what is going to be the name of this particular compound? So we say 4, 5. So we have 2 of these, so it means dimethyl. Then position number 2, we have a double bond, then we can say hexane, which can also be written as 4, 5 dimethyl, then hex 2, then in. So both names are correct. Let's look at another example. We're going to call it E. So maybe in a case where we have CH3, CH, and there's a double bond, CH, and CH2, CH, we have a CH3 here, then CH, CH, CH here. Let's try and put CH, then CH2. So here again we give respect to the double bond. So if you want to be sure, you can actually check the locant in terms of where those double bonds are. So obviously we'll consider these as a substituent, which is a methyl. So if we start counting from here, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we do the locant, we have 1 plus 3 plus 7, which gives us 11. But if we go the other side, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9. So here means that the double bond starts from position number 2, plus another double bond at position number 6, plus another double bond at position number 8, which gives you 14, 16. So you notice that the correct counting is when we start from this side, which is a red. So here we have to recognize the fact that we have a methyl at position number 5. So at position number 5, we have a methyl. Let me use a more. Okay. So position number 5, I will say I have a methyl. Then I have 3 triple bonds, remember. 1, 2, 3. So I just need to state their positions. So 1, 3, 7. Then the longest chain is a nonane. So I'll say nona. Then I have trine because they're 3. Or I can say 5 methyl. Then can say non 1, 3, 7. Then trine. Yeah. So you can encounter a lot of different complex questions, but the principle still remains the same. So let me just give you this as your exercise. CH double bond CH CH2 CH3 CH double bond CH2. So you can try this and put the answer in the comment section. See you in the next video.